Hi, good morning and good afternoon, everyone. Thanks for joining us for today's webinar by the Cyber9's team. My name is Jean-Jérôme, and I'll be looking after you for the next 60 to 75 minutes or so. Today's session is a little bit longer than our usual webinars, as we communicated in our invitations. So it's good to have you with us today. If you have any questions throughout this webinar, ask them in the question section of your control panel, or you can also use the chat box. Alternatively, if you'd like to continue conversations after the webinar, feel free to email me at jj@cyber9s.com, and we'll be looking after you there as well and answering any questions you might have as a follow-up to today's session. We're also recording this webinar, of course, so the recording will be available within the next couple of days. But for now, I wanted to give you a quick overview of Cyber9s and our product Cluster Control, which will also come into discussion a little bit today. What we do is that we specialize and have expertise in deployment, monitoring, management, and scaling of open source databases. There are three different types that we support, and I'll cover that in just a second. But Cluster Control provides users with automation and management options for their open source databases, whether it's around provisioning or monitoring or management. You can see some of the core features here that come with Cluster Control. And the databases that we support are both on the SQL and the NoSQL side. So on the SQL side, you can see here the different MySQL flavors, of course, and also Postgres. So if you're a Postgres user, you can also use Cluster Control to manage your Postgres databases with it. And on the NoSQL side, we have the different flavors of MongoDB, whether it's from Percona or from MongoDB itself. We have currently over 8,000 users who use Cluster Control in its community edition, which you can use for free and forever. But you can also, of course, sign up as a customer with us to have access to enterprise and pro features of Cluster Control. And you can see here a range of our customers, from to the entertainment industry, to technology sector, and so on. It's very broad, and of course we support all types of different customers there. So that's just a quick overview of who we are and Cluster Control, in case you hadn't heard about us before. But today's topic is on MySQL Query Tuning and Processes and Tools. My colleague Christoph is going to walk us through this presentation today. And before I hand over to Christoph, I wanted to ask all of you in the audience a question, and this is to really, I suppose, get a conversation started, and it's to see which version of MySQL you currently use yourselves in your organization, whether it's the MySQL or Percona versions of MySQL, the company, of course, Oracle or Percona versions, or maybe you use MariaDB as well. It'd be good to know on which versions of those you are. Just so we can position the conversation a little bit around that as well. So I give it a few seconds for you to provide your feedback here. And I share the results, of course, as well, once everyone had a chance to participate. So I'm going to close this poll. Thanks very much for your participation. Almost everyone was able to vote here, so I'm just going to close and share the results. So this is nice to see. We had the same session earlier today for Europe and for Asia, and MySQL 5.6 or 5.7 was just as highly represented earlier today as it is now. So that's interesting to see, and also the Percona version of that, and good to see also a bit of MariaDB in there. Christoph, any comments on this before you take over?
Yeah, sure, JJ. So yeah, I would say it's really nice mix that we have here, and basically the versions are pretty important because with MySQL 5.6 performance schema become available, and there is also a tool which we can use to leverage to collect the data about the queries, as we will be discussing later. And again, also nice to see a lot of Percona servers on MariaDB, because then, as you will learn in a couple of minutes, they give you some more additional information about your queries. So it's very useful if you're using one of them, it's very nice additional feat, I would say. So yeah, I'm looking forward to discuss this those informations in more detail.
Perfect. Thanks a lot, Christoph. And with that, I'll hand over to you for today's presentation.
Okay, thank you, JJ. So good morning and good afternoon, everyone. My name is Krzysztof Książek, and as JJ mentioned, we'll be talking today about the process and tools related to the MySQL query tuning. And this is the first part of our webinar trilogy. So we'll be focusing on not only every aspect of MySQL query tuning. We'll get to it later on. But we are going to. Okay, sorry, a little technical issues. But we are going to talk today a little bit about the query tuning process itself. So how to build test environment, how to collect your data, what methods are the best when it comes to the impact and the performance of your databases while you're collecting the data. And we'll be also discussing in detail the analysis of the data, what tools you can use to aggregate this huge amount of information that you can collect from your MySQL servers. And then we'll talk briefly about tuning and testing the those new changes, tuning the SQL and testing new changes, because we'll be focusing on those parts in the next webinars. We will also discuss in detail tools related to the query tuning process. We'll be talking about tcpdump and the PT Query Digest. So the process itself, in short, how you could put together the process in a very brief way is that you have to follow those 7 steps here. So you have to build your test environment, so you can have a place where you can do some changes, test them, test their impact, see whether they make sense to apply them or not. You have to collect your data using whatever means you have at your disposal. So you have to collect some information, metrics about the queries, about their performance, about how they are executed. Then you have to process your data, because in every busy server, if you're just collecting the information about the queries and you're running like tens of thousands of queries per second, or even 10,000s of queries per second, you may end up with a very large amount of information to deal with. So you have to process it, aggregate it somehow, to be able to actually understand and make and analyze it, so human can actually understand and see what is going on inside. And that's another step. Yeah, you have to analyze the data and derive some information, derive some clues about what is going on in your system, what queries are okay, what queries are not performing correctly, how to how to change them. And then you go to tuning the SQL and schemas. So you either have to you have to make maybe some changes in the query, maybe rewrite it a little bit, rework it slightly, or maybe you need to add an index or even remove one of them. Once you finish with that, you have to test your changes, right? So you have to make sure that the changes that you just made, they are make sense, right? They are improving your performance, not decreasing it. And then finally, you have to apply the changes to the production system. So first of all, the test environment, and this is basically a very common pattern, and it will be the same for every type of test environment that you will be building, no matter whether it's a test environment that you build because you want to test upgrade to maybe to a new MySQL version or any other means. You have to have a deterministic test environment. So because that's the I mean, this test environment cannot change in time, for example. So you have to have an ability to actually revert your changes maybe and start from scratch. And this is the only way for you to actually, measure the impact of changes. Yes, so you can make one change at a time, and then you confirm that the results are correct and that how you expect them to be, and then you can proceed further. Such environment, it should mention the production as it should mirror the production as close as possible. Obviously, you want to get the results relevant to what you will see in production, right? If you're making some tests, if you're testing a query, you want to ensure that this query will behave in the same way on production server, because that's why we are spending hours of testing, and that's why we are doing this. Yes, so we will predict how the performance on production will look like, and we won't be surprised by some unexpected issues. And then basically, it has to mirror the production as close as possible. Hardware-wise, if you're using a different hardware, obviously the results may be completely different. This is especially true when it comes to I/O subsystem. So if you're using fast storage on production, like SSDs or PCI Express flash cards, and maybe on a test development environment, you're using some kind of deprecated hardware with spindles or whatever. I mean, you're not comparing apples to apples, right? You're comparing apples to oranges or bananas. That's completely different story. So the performance will be different. The query execution will look completely different, and you cannot compare the such results. Similar case with the dataset. So you have to, you should have the same exact production dataset that you are running your tests against, because otherwise, we are talking about things like data distribution, which may change. We're talking about index cardinality, which may change if you use a different dataset. We're talking about the size of the data itself, which can, obviously seriously affect your performance, right? Maybe you have a dataset in your test environment which fits into memory, but on production it doesn't. So you're getting completely different results and completely different patterns from your test queries. So if you need to obfuscate your data for some reason, whatever, like maybe, I don't know, maybe your test environment doesn't meet your security requirements, in that case, you have to be aware that the results might be different. The query execution plans may be different because of different index cardinality, different data distribution. So you have to be, aware of this fact, and be extremely cautious when performing changes on production. That's basically it. So the best way to build a test system, frankly, is to leverage your backup. You have a backup, obviously. So you're taking the backup and you can use it to to restore restore the backup and create test environment. And this is kind of like, killing two birds with one stone, because obviously if you have a backup, right, then actually it doesn't mean that you have one unless you try to restore it and restore it successfully. So you have to, you should be testing your backups every now and then, and such a process of creating a test environment from a backup is a very nice way to first create a test environment and second test your backups. So you should restore it on a backup on a host which matches the hardware configuration of the production, and then that's about it. Yes. Ideally, you should have this type of environment running all the time, like QA staging, dev, whatever you call it. And you should use this type of environment to test every release of your application, every SQL that is being added to your application. So if you do not have it, then you should at least a couple of times per year you should build and run query performance review. And if you're a user of the cluster control and you're using a Galera cluster, then you can take advantage of the feature that we have to clone your Galera cluster. So basically, it's a very simple, easy way to create an exact copy of your existing Galera infrastructure, and you can use it too for tests. And actually, this is also important. If you're running Galera cluster on production, you should be testing against Galera cluster, not a Galera node, because it may completely change the way how, for example, queries, how DDLs and DMLs are, affecting how quick they're executed. So once we have the test environment, we have to collect the data. And probably all of you have heard about query log, which is the native method for MySQL to write down the queries that it executes. We are talking about the query review, therefore we want to have all of the queries. So we should use the long query time set to 0 to make sure that every query is logged into the slow query log. And then we will have a file filled with the most important data about every query that has been executed. So the example entry is on the slide. So we have time when the query was executed. We have information about user and host. We have information about the thread ID within MySQL, which schema was the default schema for this particular query, whether the query ended up in error and what error number it was, whether the query was killed. And then we have some metrics like query time, so query execution time, how long it took for the query to execute. Log time, which basically is information about in total how long it took for a query to collect and get every log that was required for it to execute. And then we have rows, number of rows sent to the client, to the application, rows examined on MySQL side, rows affected on MySQL side, which like rows that were modified by the query. Byte sent, which is basically a size of the data set that has been sent to the application. And then we have a timestamp and the query itself. So it's the most important data about the query, but it is still, well, most of the time it is enough. Like in this particular case, we can kind of derive that the query execution time is long, and then there is this huge discrepancy between the number of rows that we are sending to the client and the number of rows examined on MySQL side. So we are sending one row, and for that we are scanning like 60 million rows, which basically points us that most likely the query is not using an index. So most likely we should add an index on the path column. If you're running Percona server or MariaDB, the slow query log can collect even more data. So basically, there is this log slow verbosity flag variable, which can be set to full, and then you get basically this data that is shown on the slide. So the beginning is more or less the same: time, user, schema, all those metrics, and then we have information about temporary tables. So how many temporary tables the query created, how many of them were on disk, and what was the total size of the temporary tables. Then we have information about the transaction ID within InnoDB that the query was part of. And we have a couple of flags, like whether the query used query cache, whether the query made a full table scan, whether the query involved joins without indexes, whether there was a temporary table, whether there was a temporary table on disk, whether there was file sort maybe executed, or maybe it was executed on disk, how many merge passes were done for this query to execute. Then we have InnoDB statistics, as long, of course, as the query is running on the InnoDB table. So we have information about the number of read operations that were needed to execute this query. We have information about number of bytes, that's amount of bytes, the data that we had to read from the disk to satisfy this query. How long we had to, MySQL had to wait on the InnoDB IO operations for this particular query. How long it took to log rows for this particular query, and how long the query spent waiting in InnoDB queue, which is so in short, in InnoDB kernel has a limited number of threads, a configurable number of threads that can be executed at the same time. So if you are running with a high concurrency, some queries may have to wait a little bit before they can enter in DB kernel and be processed there. We also have information about the number of disk pages that have been read from accessed for this particular query. So some significant more data we can get from the Percona server or MariaDB. And we can get even more data when we set the log slow verbosity to this particular setting. So false profiling, use get error usage and profiling. So in addition to this, you will get also information about how long it took for every step in the query execution, like scanning the data, or opening tables, so on and so forth. So it's even more detailed information. Another method of collecting the data is tcpdump. So basically, the whole idea here is that we capture the TCP traffic that contains MySQL queries. So we're capturing it somewhere between MySQL database and application host. This can give you some information about the query, because when we parse this TCP traffic and we decode it, the MySQL protocol, we can see when the query started, we can see when the query ended. So it allows us to calculate query execution time. We also can see how many data was sent to the the client, so we can calculate the query size. And what is the main advantage of this method is that you don't have to execute it on MySQL host. And this is somewhat, it somewhat reduces the impact of the query collecting. So you can execute it on a proxy, you can execute it on application host, or actually you can execute it on even sometimes on some other location if you have access to the network layer and you just set up a port mirroring on your switch. So you can send the traffic to your database traffic to some other server, and there will be virtually no impact whatsoever. And talking about the impact, so here are two charts, and there will be a third one on the next slide that kind of describe what I mean by the impact. So on the left-hand side, we have different settings of the logs of the slow query log. So we have the black line where the slow log was disabled, and then a couple of other methods. So we have standard slow log without any additional data, slow log with this full information. This is extended information with performance for the Percona server at MariaDB, and then we have this full-blown information along with the profiling. As you can see, well, the impact is minimal. Well, on the first look, that it looks like the impact is minimum, except for this full profiling information. But then, if you take a look at the bottom, at this 0 line, you can see that there are dots here. Yes, and not only these magenta dots, but there are also green dots. There are also bluish dots, and it basically means that as long as you have slow query log enabled whatsoever, there will be stalls in your performance. So from time to time, there will be seconds where your MySQL server won't process any queries at all. And obviously, this is not ideal because we want to have a smooth experience for our users. We don't want them to wait like a second or two for the page to refresh, or for the action to take place. This is not ideal, unfortunately. On the right-hand side, there's the difference of we can see the impact of tcpdump. So the again, the black line is no data collection whatsoever, and then we have this visible impact of running the tcpdump. And on the slide, we kind of extend this a little bit. So here, basically, I put together 4 options. Yes, so as a baseline, we have information about, the graph covering the performance of MySQL server when the queries are coming directly to the MySQL server, and no tcpdump is running. And then we have this magenta line. Again, queries are executing directly on MySQL server with a tcpdump. So as you can see, there's significant difference in the performance. But then another 2 lines is when this green line shows the performance of our system when we are pushing the queries through AJ proxy. So we are connecting to AJ proxy and then to MySQL server. So obviously there is a difference. There's the impact of some kind of overhead of using a proxy. But then it is interesting that if you start running tcpdump on the AJ proxy, this purple violet line, the impact is not that really high compared to what you would run, if you would execute the tcpdump on the MySQL server. So basically, if you are using AG-proxy and or any other proxy, and probably majority of you will use some kind of proxy in your infrastructure, the proxy is better placed to collect the data, using tcpdump. Again, as I said, in the perfect world, in the ideal scenario would be that you can do some hardware mirroring and basically configure your switches so the port where MySQL server is located is mirrored on some other host where you can run the tcpdump. But unfortunately, if you're using cloud, this won't be possible, and not always the DBA can have access to a network layer and configure it whatever he wants. So in that case, running the tcpdump outside of your MySQL host is the best idea. Once we collect the data, we have to analyze it, because we are basically facing with thousands of lines in the log file, or in general, sometimes even tens of gigabytes of the data to process. So obviously you cannot parse it manually. There's no way. So you can either build your own tool to parse the data and to aggregate it somewhat, or you can use the industry standard, which is the Petit Query Digest tool from the Percona toolkit. So basically you can download it pretty easily, wget from the Percona website, and then you're all set. Yes, you can parse. You can use this tool to parse the either slow query log or tcpdump. It can also actually be used to parse binary logs and general log. What's important to keep in mind that this tool can be CPU and memory intensive, so you shouldn't execute it on the MySQL host. Just move those files, those logs at some other location and execute the Petit Query Digest there. And at the end, the process may take hours to complete depending on the number of data, but at the end it will provide you with a summary of the traffic along with the detailed information about every query that has been executed during the data collection process time. And then once we have the data collected, analyzed, then we can start working on the queries. So we run explain to check the query execution plan. We rewrite the queries. Then we need to test the changes. Maybe some indexes were added, maybe queries were rewritten. So then you have to test them either by running those queries like ad hoc with maybe some profiling, or you can also leverage tools like Percona Playback or PT Upgrade to compare the before and after performance of the queries. And obviously you want to make sure that your query execution plan, the new query execution plan, is better. So that's what those tests are for. And then you can leverage performance schema for a deep dive into where query execution time goes. So in the past there was the profiler added in MySQL. Actually, it is still available, although it's deprecated in favor of the performance schema. But in performance schema, you can see basically what queries were executed and on which stage of the query execution, which stage took how long. So it's very nice information about the query performance. And finally, once we have everything tested, we have to apply the changes on the production. So first of all, you have to make sure that you know what kind of impact your changes will have, and that's why we're testing them. So if you run the data tests, you should be more or less good to go with production. And then you need to execute your changes, right? So you can either run direct alters, or you can use tools like ptonline schema change or any other online schema change tools out there. Actually, if you're interested in more details, I recommend you to take a look at our webinar replay pages, because we had webinars covering this type of topic. We also had a couple of blog posts on the query on the schema changes, so feel free to take a look at those. So once you execute your changes, you need to make sure that everything's work okay. So you have to monitor your system, and it never hurts to have a rollback plan. So by the rollback plan, I mean, for example, a list of alters that would revert your changes. So if you add some indexes, let's maybe you have a list of alters you can copy paste to lead those indexes. The more problematic is when you remove, for example, unused index, and it actually is not that unused as you thought it was, because while deleting indexes is quick, adding them may take a longer time. So you have to be very cautious when you're removing some indexes from your system. And of course, you have to make sure that you monitor your system for at least a couple of days to make sure everything goes well and goes smooth, and there are no problems with some forgotten processes that take advantage of some maybe queries that you have written, or maybe some indexes that you removed, or their query execution plan changed because of some other modifications that you have made into in the schema. Okay, so before we will start discussing the tools, I will hand over to JJ for an expo.
Yeah, thanks a lot, Christoph. And the poll is, of course, related to the topic that Christoph will continue to cover shortly. And so we wanted to ask you how you typically collect your slow queries at present. So there's a few different methods listed here. It'd be great to get your input, whether it's using Slowlog or tcpdump or performance schema or port mirroring, or maybe you use some other mechanism to do so. So it'd be great to get your feedback and see what methods you're applying yourselves. And it'd be interesting to compare also to the answers we received earlier today when we did this webinar for Europe. So thanks for your participation here. I'm just I'll close the poll now and share the results. Okay, so that's actually very different, if I remember correctly, from earlier today. So you're all using Slowlog, and then a good few of you are using also performance schema. Any thoughts on this outcome, Christoph?
Yeah, actually, it is slightly different, mainly because we can see people are using different types of methods. Well, obviously, Slowlog is very popular, and most of the time the impact is acceptable. So I'm not surprised it's very frequently used. Performance schema is very also nice tool to so you can collect the data in real time and parse it on the fly and have an insight on how things are on arrival while working with the database. Yeah, and again, I would love to hear about other methods. What would you recommend? What other methods you would recommend to use? So if you like, feel free to comment it in the question sections maybe. Yeah, that would be really interesting to share some other experiences.
Yeah, absolutely. Thanks for Christoph. And on that note, feel free to ask questions about the content that you're hearing about at any point during this webinar. We'll answer the questions towards the end of it. So feel free to use the question section of your control panel and ask your questions there, and we'll take some time at the end of the webinar to answer them. But for now, thanks, and I hand it back over to you, Christoph.
Okay, thank you, JJ. So all the tools that we can use to within the query tuning process. First of all, tcpdump. I mean, we mentioned both of them, but let's discuss it in a little bit more detail. So the tcpdump, as I said, it can collect a snapshot of the TCP traffic, and it can basically contains data enough to calculate query execution time and query size. Again, not much of the detail, but it, from my experience, it is enough to pinpoint slow queries. It's enough to pinpoint queries which are not stable. So basically, that's what we are looking for most of the time. And of course, you can always, if you find some query which is not stable with regarding to the performance, you can always check, some more details. Like you can run the explain on that query to see the query execution plan, or you can even, if you want to see more details, you can even enable slow query log on the session level, execute the query within your session, and then disable the slow query log. Everything on the session level. So there are many ways you can actually get more data about problematic queries which you found using while collecting data using the tcpdump. So on the right hand side, the first bullet point, that's basically the command which will execute start collection of your traffic on a port 2306, and it will store it into a file. So that's what you want to do when you want to collect data and then parse it using, for example, PT Query Digest. So as I said, you can run tcpdump on the MySQL host, you can run it on the application server, you can run it on the proxy node. So there are many ways you can kind of minimize the impact of the tool and make the whole process, the data collection process, more smooth. The other tool, PT Query Digest. So as I said, it's a part of the Percona toolkit, and this is really amazing tool which is designed to parse the different formats of logs which provide you some query information and aggregate it. So it can work with a slow query log, it can work with tcpdump output, it can work with binary logs, it can work with general log, and probably some other methods which I don't remember because I haven't used them. What it does, it presents the data in a very nice way and easy to read. So first of all, you will see the summary of all queries, and then you will see each of the queries presented in a detailed way, as long, of course, as there is data to show, because as you can see, as we discussed, and as you will see, the amount of data which you can derive from different type of logs will vary, of course. It's very nice handy features that you have the explain commands ready to copy and paste for every query. So let's just make things much easier and nicer for DBA. The report can be modified by the user, so you can affect it. First of all, you can sort the queries in a different way. By default, it is total query execution time. But for example, you can sort it by, I don't know, maybe total rows affected, or total rows, number of rows examined, for example. Also, you can change the way how the queries are aggregated. In general, it also gives you ability to store the output, the results of your the results of its work. So basically, the parsed queries in the database, and it is a very nice feature because, for example, I mean, it allows you to first of all, add some comments and whatnot. But what is very important, you can kind of mark queries as reviewed. So maybe I don't know, maybe there is a query which that will be fixed, or maybe you just fix it by adding some index or whatever. You can mark this query in a database as reviewed, and it won't be shown in the next report. So basically, it is a way to you won't be seeing all the same queries over and over again, which is sometimes very helpful. And if you store the data, the performance metrics in the database, you can also kind of go in time and compare how the performance of a query changed in time. And this is again a very nice feature because I don't know, maybe we will see that the query started to create a temporary table, which would mean that some query execution plan may have changed, or maybe the query is making more and more I/O operations to read the data. So which means that maybe data in the table was growing and you have to do something about it, partition it maybe or whatever. So it's a very nice feature. So that's basically how you execute PT Query Digest against the slow query log. This limit equal to 100% option here is that so we will see every query in the output. By default, if I remember correctly, only the queries which are responsible for like 80%, with some value. So not every query is shown in the report, but those the most heavy ones, those which are responsible for the most of the execution time. So the report created by the PT Query Digest starts with a summary. So how many queries, how many distinct queries, when it was executed, when it was created, which host name of the host, the time range when the data collection started, when it ended. So like couple of information, and then we have a large amount of summarized data across every single query. So as you can see, we have a lot of attributes here: execution time, log time, row sent, examine, affected, temporary tables, query size, and whatnot. So basically, these are all attributes that you can find in slow query log, this extended version from the Percona server, for example. So as long as the attribute is in the slow query log, it will be listed here. And then you have those 7 columns, like the total execution time, the minimum and maximum execution time of any query, average, 95%, standard deviation, median. So a couple of statistical data which may not see, I mean, when you look at it first at the first time, it may not make any sense to include it. But once you get familiar with your workload, with your queries, you can use this data to start seeing some patterns. Like maybe, for example, I don't know, the average number of amount of rows examined increased. which would mean that some query is making more scanning more rows than it should be, or maybe a new query has been added to the query mix and is scanning rows in an inefficient way. So basically, it kind of helps you to understand the query patterns and helps to see how workload has changed just by looking at this aggregated data across every query in a slow query log. And then you have a list of queries. As I said, they are sorted by default by total execution time. And so you have query ID, which is a hash of a query digest. On the other hand, the query digest is basically like a canonical form of a query without comments. If I remember clearly, white spaces are stripped and arguments are removed. So basically, when talking about PT Query Digest, when I'm talking about queries, I'm talking about the query type, right? So, so for example, this first query, which is responsible for almost 15% of, or 35% of the total execution time, it can be, for example, select something from table where ID equal to whatever. And whatever you put there, whatever argument you put there, this is the same type of a query. So more or less, that's how it works. And then we have every query is shown with a lot of extensive information. So, and again, there is extra data for Percona Server and MariaDB. So, for example, here our first query, we can see that it's responsible for 35% of the total execution time. It's responsible for 52% of the logging time, which might kind of point us to some problems with logging, maybe. So basically, you have the same columns: total, minimum, maximum, average, 95%, rule, standard deviation, median. And again, we have all those attributes listed from the slow query log. But now we have it on a query level. It's on the query type level. So we can see that, for example, I don't know, maybe if there is high standard deviation for the execution time, this can point us to a conclusion that maybe the queries, they have sometimes it's faster, sometimes it's slower, which is not good, and which means that we need to basically investigate and understand why it happens like that. Maybe it is triggered by some locking issues, or maybe some other reason. So you have this information about, again, the DB statistics, again, as you have seen it in the slow query log. So a lot of data about the query performance, different metrics that you can kind of derive, and you can derive from them a lot of information. And at the end, there's some additional data which I believe are very important. So we have the information about this schema, host which executed this particular query, the DB transactions ID, where the query was shown. But the query histogram is the query time distribution is what I believe is one of the very important features of the PT Query Digest, because you can see here, just by looking at it, how the query performs. And this type of distribution is more or less okay, as you can see. But if, for example, we would see that we have two spikes, like maybe one here on so most majority of the queries take like between 100 microseconds to 1 millisecond. But then there is another spike, maybe let's say here, like so again, a significant number of queries take between 1 second and 10 seconds. So that would basically, should just ring an alarm bell, and this is not right. The query cannot be both slow and quick, right? So you have to see what is going on there. So you have to go there, run explain, try to see what is going on. Maybe there's some problem with locking, and maybe there's some other issues. Maybe, for example, you can see by looking at the other metrics, you can see that maybe the one query, sometimes it examines very low number of rows. Sometimes it examines significant number of rows. That would mean that there is different in in the query execution plan. So this type of query histogram is very, very useful to find type of problems. And we have the show commands for all tables involved in the query, so we can check the table status, check the show query table, and then explain for the copy paste. Of course, as we mentioned earlier, the data from tcpdump is not as detailed as the data from the slow query log. Yet it still can be used to generate important statistics. And here's basically the output of the same type of queries, but collect using tcpdump. So we have the count, we have the execution time and query size data, because otherwise others are not available. But what's important, we have also the square time execution distribution, and it also kind of can pinpoint unstable and unpredictable queries that we need to look into, and which we need to debug and see what is going on. So as I said, you can always once you pick the query which is more probably something wrong with it, you can do some additional manual analysis, and most of the time it is more than enough. At the end, we would like to also say a couple of words about the query monitor, which is available in the classic control. This is a tool which also kind of tackled the subject of the query tuning and query performance monitoring, because it provides a continuous view in a query performance. We're using basically database collected in the performance schema, as long as it is available. If not, we revert to slow query log. This is because querying performance schema is the least impacting way of collecting some of the performance metrics about the queries. It might not be suitable for a grand review, like total full-blown slow query review, but it will definitely help you on a day-to-day basis to deal with queries. And actually, it is even if you run full-blown reviews every now and then, you still should be looking for those queries. So such a tool is it will be always useful to watch your databases. What is also nice is that there is a query histogram available in the query monitoring classic control. It lists queries which had a variable execution time. So you have a list of queries which you probably want to somehow investigate and see what might go wrong, and why the execution time varies between the executions. So this is a settings page for the query monitor. If you want to use it, you need to make sure that this query sample time is set to something else than -1. So if the performance schema is available, then that's the only thing you want to change here. because other settings will not have any result on the data collection. Those are relevant when when the performance schema is not available and where you use, the query monitor has to use slow query log. And the query monitor itself, you can see that, for example, the list of top queries. So you can see a couple of performance metrics here, like a number of rows sent, rows examined, execution time, maximum average, standard deviation. So some statistical data is also visible here, total execution time, so on and so forth. What's also nice, when you click on the query, you will see the explain of it, so you can easily check the query execution time. And actually, I would like to stop here for a second, because this particular type of view is very common for the Galera cluster. So you will most likely see commit queries listed in top 5, top 10 of the slow queries. This is because how Galera works, and that the commit itself takes time due to the write set certification process, which can also, takes a little bit of time. So this is, and we can't do much about it, unfortunately, but that's basically a pretty common picture when you're performing a query review on the Galera cluster. There's also a running queries section, which I don't have a slide right now, but it's just much currently executed queries aggregated across the whole cluster. And here is a query histogram, which basically lists queries which had variable execution time, and for some reason, they weren't stable, and you might want to do some additional, digging and see what might be a reason for that. So we also had a couple of blog posts covering this topic that we covered today. So feel free to check those links and take a look and read through them. If you'd like to register for the next part of our trilogy, then again, there's a link at this page. You can click it and then register yourself. And if you're interested in cluster control, go to our Getting Started page, and and you can start from there and see how cluster control can help your monitoring and also somewhat tuning your queries. And I believe we have yet another poll. So back to you, JJ.
Yeah, thanks a lot, Christoph. And yes, you're right. We have one last poll for today that I'd like to run by all of you in the audience, and then we'll have a few minutes also to answer questions. And there were a couple of questions already, so that's good. And feel free to ask more questions in the question section of your control panel. Like I said at the beginning of the webinar, we have a bit more time today than usual, so feel free to ask questions, and we'll look into them, of course. But for now, we wanted to ask you this last question, and this is to understand how often you typically run full query reviews yourselves. So it'd be great to get your feedback here, whether you do it once a month or once a quarter or once a year. Maybe you do it after each of your release cycles, or maybe you don't do it at all. Actually, that was the case this morning also, or earlier today for our European webinar. So it'd be great to get your feedback here. And I'll let this run for a few seconds, as always, and then I'll share the results. Thanks very much for your participation here. I think I can close this now and share the results. Okay. So it's not unlike our first webinar today. So it's it's a good mix of, some of you doing this every month or once a quarter. Some don't do it at all, actually. Any comments on this, Christoph?
Yeah, so I would say this is pretty nice split. So every month and once per quarter, I think it's most of the time it is frequent enough to catch them, the main pain points. What I would like to also comment, no one's doing, query review after every release. So, I mean, if you're releasing often, that's obviously, and that's perfectly fine because it's not virtually possible to do so. But if your release cycle is, longer, then you might want to do that because it's very nice way of making yourself familiar with the new code, new SQL, and so on and so forth. Yeah, and for the people who don't perform query reviews, I would really recommend to try implement this process because, I mean, personally, I find it really refreshing to see and to understand better my systems when I go through all the queries which are out there, and it makes, personally for me, it always made much easier to manage the systems when I know the workload patterns, when I know the pain points, so on and so forth. So yeah, I would strongly recommend to try.
Thanks a lot, Christoph, and thanks everyone for participating in this post. So we have a few minutes still to answer some questions, so I guess let's get started straight away. So Christoph, there's a question here from Jose, and he's asking whether PT Query Digest can be used in a Windows environment.
I'm definitely not familiar with Windows environment. But in general, PT Query Digest is a Perl script which parses text file. So as long as you can configure your environment to execute Perl scripts, I don't know, Cygwin maybe or whatever, tools like that, it should work. So that's basically, a Perl script. So you may try. Maybe there will be some problems with dependencies, but I mean, as I said, I have to comment on that. I've never tried it.
Okay. Well, thanks, Christoph, for this. And Jose, if you have further questions on that, feel free to ask them and by using your control panel. And there's a question here from John, and he's asking if there's an easy way to find unused indexes that you could recommend.
Yeah. So basically, if you run on a server or MariaDB hosts, then there is the table. I mean, they have user stats variable which you can enable, and then there is a table in the information schema that covers, if I remember correctly, it's index stats or index statistics, which basically stores the data about the indexes. So you will see what type, how many rows were accessed through this index, or how many rows were modified through a particular index. So that's a very nice way to find the unused indexes. And actually, if you're running 5.6 or later, there's a performance schema. So as long as you have the weight instruments enabled, then there is there's a table which I can't remember from the top of my head, but there's a table which basically prints the more or less the same type of data about the index usage. So you can, with a little bit of SQL, you can easily check the index usage using the performance schema.
Great. Thanks a lot. Thanks a lot, Christoph. And there's a question here from Nisha, and the question is whether there is a way to find out fragmented tables to optimize.
Okay. So first of all, I wouldn't. I mean, I wouldn't be very concerned about table fragmentation. I mean, it is obviously a problem, but it is not as that huge issue as you would see from the performance perspective. Frankly, I am not aware of a method to do that, unfortunately. I mean, obviously, you can optimize them, but just running an alter in a DB table. So that's about it. But to be honest, I would have to search for that for this information, because I haven't heard about some method that would be that could be used here. So if you could get in touch with JJ, the contact is at the screen at the end, jj@several9s.com. I will try to do some research on that, but frankly, I haven't heard about it.
Okay, fair enough. No, thanks a lot, Christoph. And Janisha and anyone else, if you want to ask further questions on this or other topics, feel free to use this email address, which is mine, jj@several9s.com, and we'll get back to you via email then on those questions. There was a question here from Wilson, but it's very specific, so Wilson will answer that question directly via email. I think that might be easier. So we'll do that, and I think for now we don't have any further questions, and we're just coming, I think, towards the end of the webinar. So I wanted to thank all of you for your participation today. Thanks, Christoph, for the presentation. You have some links here again, that you can follow, of course, blog posts, that covered the topic of query tuning. Also, please do register for the next part of this trilogy. So there are 2 more parts coming up on this query tuning webinar series. And of course, if you'd like to check out and test class control, you can do that also by using this Getting Started link here. But for today, thanks very much for your participation. Have a good rest of the day, and we'll be in touch with the replay details within the next couple of days as well. So look out for details on that. Thanks, and talk to you soon. Take care. Bye-bye.